Okay guys, 1.2 has a lot of definitions as well. Explanatory variable is a variable that affects the value of the response variable. In the scientific method, you have things that you change to kind of see what effect they have on the outcome. And that's the explanatory variable, the things you change. And the response variable is the goal. It's what you're measuring. So these have different terms in science, but they're the same kind of things. Observational study measures the value of the response without attempting to influence it. If you're just watching what's happening without trying to influence it, that's an observational study. An experiment requires you to be changing things so you can affect the outcome. A study is like a poll, trying to see what people think or how people behave. A designed experiment, a researcher assigns the individuals in the study to a certain group, intentionally changes a specific variable, and then sees what happens. Confounding is when two variables aren't separated. Any relationship that maybe exists can cause the response variable, and then you don't really know which one is the primary cause. A lurking variable is something you don't consider that could affect the outcome. And then census is a list of all individuals in a population along with certain characteristics. To determine if it's observational or experiment, rats with cancer are divided into two groups. One receives 5 milligrams of a medication, the other receives 10. After 2 years, the spread of cancer is measured. So were they trying to affect the outcome? Yes, then it's an experiment. A poll is conducted in which 500 people are asked which is better, plain or peanut M&Ms. Unless the wording on the poll is strange, are they influencing the outcome? No, so it's an observational study. Conservation agents netted 250 bass in a lake and determined how many had parasites. Are they influencing the outcome? No, it's an observational study. And that's all for 1.2, so we'll just skate on into 1.3. Okay, 1.3 talks about sampling. A simple random sample is every member of a population has an equally likely chance of being picked. Big N represents the number of individuals in a population, while little n represents the number in a sample taken from the population. A frame is a list of all individuals in a population. You'll pretty much never make a frame for any population that's significant because it requires too much writing out. And that's all for 1.3, its definitions. 1.4 are different types of samples. These are determined by how you pick your sample. A stratified sample is obtained by separating the population into non-overlapping groups, so everyone gets assigned a group, and then taking the same number from each one randomly. The individuals within each stratum should be similar in some way. So if you wanted like a sample that represented both genders, you might separate all the men and women who have a characteristic and take 50 of each of them for your 100-person sample to avoid the possibility of possibly picking like 80 men and 20 women and not really getting an ideal representation of what people believe. A systematic sample is obtained by selecting every kth individual from the population. For example, you number people off and you take every 17th person. That would be systematic. You have a system and you don't go away from it. Cluster sample is where you separate people into groups and everyone within a specific group is picked. So let's say I have a class of 20 and I separate them into 5 groups of 4. I'm going to take 2 groups and take all 4 people from each of those 2 groups. That's a cluster. Convenience is where you just easily obtain whoever's the easiest. It's usually the least accurate. If you take a sample of the first 20 people you see in City Hall about how they feel about City Hall, chances are you've got 20 workers in City Hall. That probably doesn't represent the people's actual beliefs. Decide which type of sampling is used. To estimate the percentage of defects, a quality control manager selects every 8th chip that comes off the assembly line. It's doing the same thing each time. It's systematic. To Determine the prevalence of human growth hormone used among high school baseball players. The State Athletic Commission randomly selects 50 high schools. All members of the high school's baseball teams are tested. So every high school is put into its own cluster, and whole clusters are picked. So this is a cluster sample. A member of Congress wants to determine her constituency's opinions regarding estate taxes. She divides her constituents into 3 household income levels, high, middle, and low. She then takes a simple random sample from each. She stratified them and then took a sample. Number 4 is on the next page. A radio station asks its listeners to call in their opinions regarding troops overseas. If you're listening to a radio station, especially if it's a news station, chances are your listeners already agree with you. So this is a sample of convenience. It may not be very accurate. And lastly, 24-Hour Fitness wants to administer a satisfaction survey to its current members. Using its entire roster, the club randomly selects 40 members. You're like, well, is it systematic, cluster, convenience, stratified? It's none of those. This is the best way to do it. This is just a simple random sample. A baseline simple random sample. People forget about it because we just talked about 4 types of sampling, but the original one is the simple random sample, and it can be that. Now, in addition to samples, there's also bias. And that's when the results of a sample are not representative of a population as a whole. There are different types of bias. Sampling bias, techniques used to obtain the samples, individuals tend to favor one part of the population over the other. For example, if that lady hadn't stratified her people into income levels, low and maybe even medium income people don't care about property taxes. The only responses she would have gotten back are people who make large incomes, have a lot of property, to care about the property taxes. Non-response bias occurs when individuals selected to be in the sample who do not respond to the survey have different opinions from those who do. A perfect example of this would be if police officers decided to go door to door. The people who answer the doors for the cops are probably ones who have a positive opinion of them. The ones who don't answer, don't respond at all, probably are more scared and have a less high opinion of cops. Response bias exists when the answer on a survey do not reflect the true feelings of the respondent, and we'll see this coming up, the obvious one. Determine the type of bias. An anti-gun advocate wants to estimate the percentage of people who favor stricter gun laws. He conducts a nationwide survey of 1,203 randomly selected adults, asking the question, do you favor harsher penalties for individuals who sell guns illegally? You're like, that question doesn't represent favoring stricter gun laws. This is the response bias, generally speaking, because the wording of the question misrepresents what the person responding is going to say. Well, most people do favor harsher penalties for people who sell guns illegally, but that doesn't mean they favor stricter gun laws in general. A retail store manager wants to conduct a study regarding the shopping habits of its customers. He selects the first 60 customers who enter the store Saturday morning. The people who come to your store in the morning, right when it opens, the first 60 probably don't represent the whole population, so I would call this a sampling bias. He picked 60 people who come to the store at the beginning. That doesn't represent the whole population of shoppers for the store. A member of Congress wants to determine her constituency's opinions regarding estate taxes. She divides her constituents into 3 household income groups, high, middle, and low. She mails out 100 surveys to random people from each one, and a total of 112 are returned. Okay, so her sampling technique was good, but if she only got 112 of the 300 back, this is probably non-response bias, because again, it's the wealthy people who would have responded most likely. And there could be some response bias depending on how the question was done, but I would say the main thing is a non-response bias. So we'll put response bias question mark. Okay, this is the second part of chapter 1. I'll go ahead and put the last video up next.